Welcome to Top Niche Market, where we decode the innovations that are shaping our tomorrow. Today, we're not just talking about a new gadget or a minor upgrade. We're diving deep into a revolution that's happening right now in labs and factories around the world. This is the story of the quantum design battery, a technology so transformative it promises to make gasoline cars feel like horse-drawn carriages and power grids. Run on fossil fuels, a relic of the past, potentially within the next decade. This isn't science fiction. This is the blueprint for our clean energy future, and it starts by understanding the prison we're currently in. Let's be honest with ourselves. We've all felt that familiar pang of anxiety. The sinking feeling when your phone flashes that dreaded 10% battery remaining notification, and you're miles from a charger. Or the range anxiety that EV drivers talk about. The constant mental calculation of whether you'll make it to the next charging station on a long road trip. Now, imagine that same anxiety, but scaled up to the entire planet. That is the reality of our global energy system. We have incredible sources of clean energy, the sun that bathes our planet in power every day, the wind that whips across our plains and oceans. The problem has never been a lack of energy. It's been our inability to effectively catch it, store it, and use it when we need it. The hero of the last decade has been the lithium-ion battery. It's in our phones, our laptops, our electric cars. It made the portable electronics revolution possible. But this hero has a dark side, and it's reaching its absolute limit. Think of current lithium-ion batteries as a bucket made of paper. It can hold water, sure, but it's fundamentally flawed. First, it's expensive. The materials inside, like cobalt and lithium, are often called rare earth elements. The mining of these materials is environmentally destructive and often tied to unethical labor practices and geopolitical instability. Countries that control these resources hold immense power, creating a new kind of energy dependency, not unlike our reliance on oil. Second, the bucket leaks. Every time you charge and discharge your phone, tiny irreversible bits of damage occur inside the battery. Over time, it holds less and less charge. That's why a 2-year-old phone barely lasts a day, while a new one goes much longer. This degradation means we are constantly manufacturing and discarding batteries, creating a massive e-waste problem. Third, the bucket is slow to fill. Charging an electric car can take anywhere from 30 minutes at a supercharger to 8 hours at home. It's a far cry from the 5-minute stop at a gas station we're all used to. This inconvenience is a massive barrier to widespread EV adoption. And finally, and perhaps most frighteningly, the bucket can catch fire. The liquid electrolyte inside a lithium-ion battery, the water that allows energy to flow, is highly flammable. If the battery is damaged or has a manufacturing defect, it can lead to a phenomenon called thermal runaway, causing the explosive, hard-to-extinguish fires we've seen on the news. On top of that, a microscopic villain called a dendrite can grow inside. Imagine a tiny, sharp metal icicle forming within the battery. If it grows long enough to pierce the internal barrier, it causes a short circuit, and boom. For decades, brilliant scientists have worked to improve this paper bucket. They've tried new materials, new additives, new chemical recipes. But they've been stuck in what the industry calls the battery valley of death. A promising material might work beautifully in a tiny lab-scale coin cell battery. But when they try to build a battery big enough for a car, it fails spectacularly. The chemical interactions behave in wildly unpredictable ways at scale. It's like having a recipe for one perfect cupcake, but finding it impossible to bake 1,000 of them without the whole batch collapsing. This trial and error approach has hit a wall. We can't build our future on a foundation of guesswork. To escape this valley of death, we needed a new map, a new way of seeing. We needed to go quantum. So, how do you solve a problem that's rooted in the unpredictable dance of atoms? You learn the steps to their dance. This is where quantum computers come in, and they are changing the game entirely. To understand the difference, Let's use an analogy. Imagine you're a chef trying to invent the world's greatest new dish. Using a classical computer is like having a cookbook with a billion recipes. To find the best one, you have to cook each recipe one by one, taste it, and rate it. It's a slow, painstaking process of trial and error. You might find a good recipe, but you'll likely never find the perfect one. Now, imagine you're a quantum chef. A quantum computer doesn't read the cookbook one recipe at a time. It's so powerful it can essentially conceptualize and taste all 1 billion recipes simultaneously. It can understand the complex interactions between every single ingredient in every possible combination all at once. It can then tell you, here, this is the perfect combination of ingredients cooked at this exact temperature for this exact time to create a dish beyond anything you've ever imagined. That is what quantum computing is doing for battery design. For decades, chemists were mixing materials in the lab, hoping for a breakthrough. It was guesswork. Now, with quantum simulations, they can model the behavior of electrons and ions at the subatomic level with perfect precision. They can ask the computer, what happens if we arrange carbon atoms in the specific crystal lattice? How will lithium ions flow through it? Will it be stable? Will it store a lot of energy? Will it be safe? The quantum computer can simulate thousands, even millions, of potential new materials and structures in a matter of hours. Experiments that would take centuries to conduct in a real-world lab. It's a fundamental shift from empirical guesswork to predictive engineering. We are no longer stumbling in the dark. We are designing batteries with atomic-level precision, from the ground up, to have the exact properties we desire. And the first incredible breakthrough from this new approach is a material that solves nearly all the problems of our old paper bucket. One of the first and most profound breakthroughs to emerge from this quantum design process is the solid-state electrolyte. This is the silver bullet that addresses the safety, speed, and density limitations of current batteries. Let's go back to our battery analogy. In a traditional lithium-ion battery, the electrolyte is a flammable liquid. Think of it as a chaotic public swimming pool. Ions, the energy carriers, have to swim through this liquid to get from one side of the battery, the anode, to the other, the cathode. It's slow, it's messy, and the liquid itself is a fire hazard. A solid-state electrolyte designed using quantum simulations is completely different. It's a thin, solid ceramic or polymer material. It's not a swimming pool. It's a perfectly engineered multi-lane superhighway for ions. The quantum simulations allowed scientists to design the exact crystal structure of this material, creating perfect, tiny tunnels that are precisely the right size and shape for lithium ions to zip through at incredible speeds. The implications are staggering. First, safety. Because the electrolyte is a solid, it's not flammable. The risk of battery fires is virtually eliminated. You get all the power without the danger. Second, charging speed. On this ionic superhighway, there are no traffic jams. Ions can move back and forth far more quickly. This is what enables the 10-minute charging we talked about. Imagine pulling your EV into a charging station, plugging it in, and by the time you've walked inside, used the restroom, and bought a cup of coffee, your car has gained 500 miles of range. That's not a future dream. That is the direct result of this technology. But the biggest advantage is what this new, safe superhighway unlocks. It allows engineers to use the holy grail of battery materials, a pure lithium metal anode. In old batteries, using pure lithium was a suicidal idea. It was so reactive with the liquid electrolyte that it would trigger those dangerous dendrites and cause fires almost immediately. So engineers had to settle for graphite, a much less energy-dense but safer material. Graphite is like a bulky, inefficient parking garage for lithium ions. A pure lithium metal anode, by contrast, is pure energy density. It's like replacing a huge parking structure with a sleek, impossibly dense material that can hold 10 times the energy in the same space. With a solid-state electrolyte making it safe, we can finally use lithium metal. The result? A battery that is lighter, smaller, and vastly more powerful than anything we have today. This is the technology that will give us 500-mile EVs, grid storage that can power a city for days, and a foundation for an energy revolution. But a battery is a system, and the quantum revolution didn't stop with the electrolyte. It has also transformed the other critical components. Think about the cathode. If the anode is where the energy is stored, the cathode is the destination it travels to. In our car analogy, if the anode is the home garage, the cathode is the office parking garage. The efficiency of your commute depends on how well both garages are designed. Quantum simulations have allowed researchers to design cathode materials with perfect crystal structures. Imagine a parking garage where every single spot is perfectly angled. The lanes are wide, and there are express ramps for entry and exit. That's a quantum design cathode. It allows lithium ions to slide in and out with almost zero resistance or damage. The result is a battery with a dramatically longer lifespan. We're not talking about a battery that degrades after 500 or 1,000 cycles. We're talking about batteries that can endure tens of thousands of cycles with minimal loss in capacity. For an electric car, that means a battery pack that could outlast the car itself. For grid storage, it means an asset that can operate reliably for decades. And what about our old villain, the Dendrite? Quantum design has a solution for that too. Scientists have used simulations to create atomically engineered surfaces on the electrodes. These surfaces act like a gentle, intelligent guide for the incoming lithium ions. Instead of ions randomly crashing onto the surface and piling up to form those dangerous needle-like dendrites, this new surface guides each ion to lay down flat in a perfectly smooth, uniform layer. It's like having an invisible traffic controller at the atomic level, ensuring a perfect safe landing every single time. By designing the problem out of existence at its most fundamental level, we solve the safety and longevity issues that have plagued batteries for a generation. This all sounds incredible in theory, but the most exciting part of this story is that it's no longer just theory. The leap from quantum simulation to the real world is happening with breathtaking speed. The battery valley of death is being bridged by the power of predictive design. Automotive giants like Toyota have already announced their plans to launch vehicles with solid-state batteries by 2027. They're promising ranges of over 500 miles, with charging times under 10 minutes. This isn't a vague press release. They are building the factories right now. Think about what that means. The primary arguments against EVs' range anxiety and long charging times will evaporate almost overnight. A 10-minute fill-up makes an EV just as convenient as a gasoline car, but with a fraction of the running costs and zero emissions. Meanwhile, companies like Tesla, already a leader in battery technology, are aggressively integrating these next-generation chemistries into their grid-scale storage solutions, the Megapacks. Imagine a massive solar farm in the desert. With current batteries, it can provide power for a few hours after the sun goes down. With quantum-designed batteries, that same solar farm could store enough energy to power a major city like Los Angeles or New York for several days straight, through clouds, rain, or night. This makes renewable energy not just a supplement to the grid, but the stable, reliable foundation of the grid. Blackouts caused by overdemand during a heat wave could become a thing of the past. And because these batteries are designed with precision from the atom up, manufacturing becomes more like printing a computer chip than mixing a chemical brew. The quality is incredibly consistent, yields are higher, and costs come down. This isn't a boutique technology for the rich. This is a scalable solution for the entire planet. The revolution is already on the assembly line. When a technology this fundamental changes, it doesn't just create a new product. It reshapes the entire global landscape. The economic and environmental impact of quantum-designed batteries will be a tsunami of change. Economically, analysts are projecting this market to be worth an astonishing $2 trillion by 2035. This is not just about selling more cars or batteries. This is about the birth of entirely new industries. We're talking about a complete overhaul of our energy infrastructure, our transportation systems, and our manufacturing base. It will create millions of high-tech jobs in materials science, engineering, and advanced manufacturing. Furthermore, these new batteries are being designed with abundant, ethically sourced materials. Quantum simulations can screen for materials that are not only effective, but also cheap and plentiful, like sodium or sulfur, reducing our reliance on an unstable supply chain for cobalt and lithium. This will democratize energy storage, making it affordable for developing nations and creating a more equitable global energy system. The geopolitical map will be redrawn. Nations will no longer be defined by their oil reserves, but by their innovation in energy storage. Energy independence will become an achievable reality for countries around the world. Environmentally, the impact is even more profound. This is the technology that finally makes a zero-carbon future possible. Grid-scale storage is the missing link that makes renewable energy sources like wind and solar truly viable 24/7. When the grid can store massive amounts of clean energy, we can begin to decommission our coal and natural gas power plants, one by one. Our cities will have cleaner air, our skies will be clearer, and we can finally, meaningfully combat climate change. This isn't just about reducing our carbon footprint. It's about building a truly sustainable civilization. With a revolution of this magnitude comes an unparalleled wave of opportunity. The quantum battery space is already seeing a massive influx of investment, creating a dynamic landscape for those looking to be part of this future. We're seeing a classic split. On one hand, you have nimble, high-risk, high-reward startups born out of university labs that are pioneering radical new battery chemistries. Investing in them is a bet on a breakthrough that could change everything. On the other hand, you have established manufacturing giants, the Toyotas, Teslas, Samsungs, and Panasonics of the world, who are acquiring these startups or building their own massive R&D wings to integrate this quantum capability. An investment in them is a bet on scale and execution. And the future potential is even more mind-boggling. The advancements we're seeing now are just the beginning. The next wave of quantum-designed batteries could enable technologies we can barely imagine today. Batteries that charge in seconds, not minutes, blurring the line between a battery and a supercapacitor. Batteries that can store energy for months with minimal loss, allowing us to capture summer sun to heat our homes in the dead of winter. Structural batteries, where the body of a car or the wing of a plane is the battery, making vehicles lighter and more efficient. Batteries that can harvest ambient energy from radio waves or vibrations, leading to devices that may never need to be plugged in at all. This technology is the bedrock upon which future innovations like electric aircraft, autonomous robotics, and hyper-connected smart cities will be built. The investment isn't just in a better battery. It's an investment in the entire platform of 21st century technology. So what does all this mean for you, for me, for our daily lives? It means an electric vehicle that is cheaper to own, faster to refuel, and more exciting to drive than any gasoline car. It means a home powered by rooftop solar panels that can store enough energy to keep your family safe and comfortable through a week-long blackout. It means a smartphone, a laptop, a watch that holds a charge not for a day, but for weeks on end. This isn't a distant, abstract future. The wheels are already in motion. The factories are being built. The change is coming faster than any of us can imagine. The lesson in this incredible story goes beyond just technology. For a century, we approached problems like energy storage with brute force endless trial and error, hoping to stumble upon a solution. The quantum revolution teaches us a profound lesson. The greatest breakthroughs come not from working harder, but from understanding the problem at its most fundamental level. By using new tools to see the world in a new way, we can design elegant solutions on most intractable challenges. This mindset is something we can all apply in our own lives. When faced with a difficult problem, Instead of just trying random solutions, take a step back. Try to understand the root cause, the underlying system. Seek out new perspectives and new tools for thinking. That is where true innovation, whether in a high-tech lab or in your personal life, is born. We are standing at a pivotal moment in human history, on the cusp of a truly sustainable energy future. The transition will be challenging, but for the first time, the path forward is clear, and it is illuminated by the power of quantum design. So now I turn it over to you. What part of this quantum battery revolution excites you the most? Is it the impact on electric vehicles, the potential for a 100% renewable grid, or the personal convenience of devices with ultra-long battery life? And what do you think the next great challenge will be once we've solved energy storage? Share your thoughts in the comments below. I'd love to read them. Thank you for joining us on Top Niche Market. I wish you and your loved ones good health and boundless curiosity. If you found this journey into the future of energy inspiring, please give this video a thumbs up. And don't forget to subscribe and click that bell icon so you won't miss our next exploration into the technologies that are redefining our world. Until next time, stay curious.